and welcome to this first webinar of ASEP. I am actually privileged to be the first speaker of this ASEP's webinar series. And today I will be presenting to you some of the approaches and codes and standards that we normally use in conducting structural evaluation of existing structures. So the outline of my presentation for this afternoon would be as follows. First, I would like to discuss the different reasons why we want to conduct a structural evaluation on an existing structure, followed by some of the approaches, codes, guidelines, and standards in conducting these evaluations. And then we dive in specifically in conducting a structural evaluation or seismic evaluation of existing structures, where I will provide an overview of the ASCE 41 standard, and I will also introduce to you the International Existing Building Code. And then I will present an hypothetical example that would give us some insights on the difference in conducting an evaluation using a code-based evaluation and using a performance-based evaluation. So please allow me to start. So the first thing that we should know when conducting structural evaluation is knowing the purpose why the owner or the stakeholder wants us to conduct a structural evaluation. Why does the owner want us to evaluate their structure? Now, in doing so, we need first to have a definition of what is really a structural evaluation. And these descriptions that are given in this slide are basically based on our experience and practice, and based on the experience of the colleagues in the industry of structural engineering. So basically we can define, or structural evaluation can be defined as a process of determining the capacity of an existing structure in relation to the level of service that it actually provides. Now, when we say structural evaluation, the evaluation may include a structural assessment or a structural analysis, or both. Now, when we say structural assessment, it may include a condition assessment, which aims to determine the extent and sources of defects in an existing structure, and may also include determination of in-place properties of the materials using both destructive and non-destructive methods. Now, a structural analysis, on the other hand, is performed to compare the capacity of existing structural members to their structural demands. Now, in the Philippines, that is a normal reaction to structural engineers who were asked to conduct a structural evaluation to assume that the evaluation is a seismic evaluation. Now, this is clearly understandable because being an earthquake-prone country, and time again as structural engineers in our practice, we prove that the governing load cases in most situations are the load combinations that include earthquake loadings. But there are several reasons why we conduct structural evaluations. And in this slide, I categorize these different purposes of structural evaluation into three. The first one being the change in resistance or change in strength. So we conduct a structural evaluation because there is a change in the capacity of the structure. There is a change in the intended capacity of the structure. Now, we also conduct a structural evaluation because there is a change in loads or structural demands. Or we also conduct structural evaluation when there is an aging in the structure. There's a recognized aging in the structure. Now, under these categories, we can actually define in detail what are the reasons behind this change in strength, change in loads, and aging in structures. So starting with the structural evaluation that is triggered by what we call a change in resistance or change in strength. Now, one of the reasons why there is a change in strength or change in resistance in the structure is because there's a damage in the structure. And therefore, if there's a damage in the structural evaluation that we want to perform is what we call a damage assessment. Now, a damage assessment is performed basically to determine the extent of damage incurred by the structure to certain events, such as earthquake, typhoon, and fire. Some examples given in the slides are some of the damage observed in a structural building, a school building, after an earthquake, in the 2019 Cotabato earthquake, and a fire damage part of the Skyway 3 project. Now, structural evaluation is also conducted whenever there is a change in resistance because of the deterioration of the structure. And this type of evaluation is what we call a structural condition assessment. Now, this assessment is normally requested when there is a visible evidence of structural deterioration, such as cracking and corrosion of steel and steel reinforcement. So in the figure, we can see some spalling of concrete, which is induced by the corrosion of reinforcement. So if you are conducting a structural evaluation, your goal is to determine the source of this corrosion, whether it is a carbonation-induced or chloride-induced corrosion. And you may want also to check the crack widths in an existing structure and compare them with some allowable or tolerable crack widths. For example, we allow 0.41 millimeter crack width for interior structural members, and you may want to compare if the cracks in the existing structure are actually exceeding those limits. Then you may want to check also if there is a reduction in the pH of concrete, which may actually trigger the corrosion of reinforcement. So we want to determine the depth of carbonation and compare it with the concrete cover depth to check if there is already a potential for corrosion to occur. Now, another triggering mechanism why we would conduct a structural evaluation is where there is a change in resistance because of the inadequate use of materials, maybe unintentionally during construction. Now, this structural assessment may be required when the capacity of the structural member is in question because of possible low compressive strength and similar flaws during construction. Now, some of the different conditions where we conduct a structural evaluation due to a change in loads is when there is a change in occupancy. Particularly, it is required when where there is a change in use in the structure, such as changing the structure from a residential facility into a storage area or a commercial center. Then commonly a structural evaluation is required. Now, another reason is when there are building addition or alteration. For example, the owner would like to add additional story to the existing building, and in such cases, structural evaluation must be performed in order to check if the existing structure can accommodate or has the residual capacity to accommodate the addition. Now, we also do structural evaluation when there is a new equipment added to the existing building, which is very common in manufacturing industry. For example, the industry would like to increase the production of the plant and would like to introduce this new equipment. So structural evaluation is needed to determine if the existing structural elements can be able to support this added equipment or machinery. Now, with regard to the structural evaluation that is triggered by the aging of structures, one of them is what we call structural integrity assessment. Now, this evaluation is performed when the existing capacity of structural elements are in question because of the age of the structure. Now, this evaluation normally consists of both structural assessment and a structural analysis. And this is normally performed in old structures that do not qualify as heritage structure. Now, aging of structures also include the structural evaluation and restoration of historic landmarks. Now, the structural evaluation of heritage structures requires special treatment, as conservation principles normally govern the repair strategy. Now, the challenge in doing an evaluation on heritage structures is how to properly characterize the materials used in the original construction, and basically how to maintain the intervention at minimum in order to retain the historicity of the structure. Now, there is also a type of structural evaluation that is normally performed on an existing structure when there is what we call a property acquisition. And this type of structural evaluation is what we call structural due diligence. So basically, this is performed to assess the in-place structural condition of an existing structure, normally during a property acquisition. And the aim of the investigation really is to determine the structural risks associated with the future use of the building, which can be used as an appraisal to the structure. And of course, the most common structural evaluation performed here in the Philippines is a seismic evaluation. And the seismic evaluation is really conducted to determine if a structure has an adequate resistance to an earthquake. Now, normally it is triggered by the age of the structure, particularly if a structure was actually designed and constructed prior to the implementation of a comprehensive seismic code. Now, with this introduction of different types of triggers for us to conduct a structural evaluation, we go now to what are the codes, standards, guidelines, and references that we can use in conducting these different types of structural evaluation. Now, when there is a what we call change in resistance, and when we want to do a damage assessment, for example, for buildings that were subjected to earthquake, a common type of damage assessment that we perform is what we call a post-earthquake evaluation. Now, it is performed to existing structures that were hit by a large magnitude earthquake. Now, a common reference to use in conducting such evaluation is what we call the ATC 20, published by the Applied Technology Council. Now, a very good initiative by ASEP is the introduction of the Disaster Mitigation Preparedness and Response Program, what we call DAMPER, which actually provides you a training on how to perform such post-earthquake evaluation. And it follows a similar procedure to that of ATC 20. Now, you may also perform a damage assessment when a structure is damaged by fire. And in terms of codes and standards, there is no really consensus document that is used in the assessment of structures damaged by fire. In some cases, you can actually use as a reference the TR68 guide from Concrete Society. It's a European guideline. And it will tell you that some of the important information that you need to collect during a damage assessment of a fire damaged structure are the concrete cover, the duration of fire, basically to determine the maximum temperature where the elements were exposed, and also the source of fire, so that you can see the variation of temperature across the structure. Now, of course, if you are to conduct a structural condition assessment Again, the intent is to determine the source and extent of deterioration in existing structure. Now, in conducting a structural condition assessment, it is normally supplemented by destructive and non-destructive evaluation of existing materials. And in conducting such evaluation, the ASCE 11 is normally used as a guide in performing this assessment. Now, for structural evaluation that are induced by the change in structural demands, of course, the main code or standard that we use in assessing a structure that is where there are change in use or occupancy is what we call the National Structural Code of the Philippines. So basically, whenever there are some evaluation that were triggered by the addition of floor area, addition of story, then normally we use the new code provisions in order to evaluate if the existing structure can support additional loadings. And of course, we know the NSCP is a compendium of several standards, such as the IEBC for the earthquake, ASCE 7 for wind, and so on. Now, for codes, standards, and guidelines we use in evaluating existing structures that were induced by the age of these structures, we have the following. Now, in conducting a structural integrity assessment, for example, particularly when the focus is not really on the seismic evaluation, but on the gravity assessment of existing structures. And in doing so, we normally use, again, the National Structural Code of the Philippines in performing the evaluation. And also, there's a new standard that was released by ACI. We call it the ACI 562. Can also be used to evaluate an existing structure, even if you are only assessing the gravity system of the structure. Now, the ACI 562 is also performance-based in nature, and it also refer to the ASCE 41 if you are conducting a seismic evaluation. ACI 562 has its own set of load combination as well as reduction factors, so it can be used as a standalone standard in evaluating an existing structure. Now, how about for heritage structures? Now, in heritage structures, there is also no local consensus or even an international consensus on what standard to use in doing this evaluation. But there are references, and one of the best references that I can recommend is what we call the Secretary of the Interior's standard for the treatment of historic properties. So it is not really a technical reference, but rather is a practical reference that gives you a guide in how to preserve, how to prioritize structural elements in doing the evaluation of this historic structure. So basically, this document already includes that aspect of conservation in doing the evaluation. Then we also have other references from IEBC, the SED 15, as well as some of the case studies of IEBC. Now let's move on now to seismic evaluation. And I understand that all of us here have already encountered someone who asks us to perform a seismic evaluation of their existing structure. Now, in conducting such evaluation, it is a natural question among the practicing structural engineers on what code to use in conducting such evaluation. Are you going to use a performance-based philosophy in evaluating an existing structure, or are you going to use a code-based philosophy in an existing structure? So to answer this question, I allotted each part of this presentation on discussing how to do a seismic evaluation of an existing structure, what are the approaches, what are the codes and standards that we can use to perform such evaluation. And to do so, we need to define what is a seismic evaluation and why do we perform seismic evaluation of existing structures. Well, we perform seismic evaluation of existing structures because we all know that existing structures, particularly those that were designed way back before the implementation of a stringent seismic code, are actually expected to be non-conforming to the prescripted rules of the new seismic code provisions. The objective is not to redesign these buildings to meet new code provisions, but really just to manage the seismic risks by understanding how these structural components will behave and respond under earthquake shaking. And our objective really is to provide a minimum level of safety. Now, again, the natural question among structural engineers is what code or standard to use. Now, I would say that there are two groups of engineers that are somehow debating on this one. There's this what we call a code-based approaches and what we call performance-based approaches. Now, code-based approach in evaluating an existing structure is commonly preferred because of its simplicity and, of course, our familiarity in using a code-based procedure to evaluate an existing structure. Now, there are also people who prefer the performance-based approach because of its capability in quantifying the response of a building against an explicit target performance that is not directly feasible under traditional prescriptive design standards. So it is a common question to all of us, what approach to use in evaluating an existing structure. Now, these are the standards and codes that we use in doing seismic evaluation. Again, it can be a code-based approach, it can be a performance-based approach. Now, in the code-based, we normally use the NSCP, and in performance-based evaluation, we normally use the ASCE 41. Now, there are other references available in the literature, such as the ACI 562, and some old references, such as the FEMA 273. But what I would like to introduce today is the use of what we call the International Existing Building Code. Now, what is this International Building Code? Well, this one is a model code. It's a model code for evaluating existing building. And today, I would like to focus my discussion on ASCE 41 and the International Existing Building Code. Now, these two references can be considered as the two current state-of-the-art references in evaluating an existing structure, particularly when we are conducting seismic evaluation. In both methods, the evaluation consists of structural assessment and structural analysis. ASCE 41 is a standard, while IEBC is a model code that has already been adopted in the US. Now, I would like to start by providing some overview of ASCE 41. Now, what is ASCE 41? And I'm sure from the several conferences and lectures that we have, we always hear about this ASCE 41 standard. So basically, this standard uses a performance-based design philosophy in performing seismic evaluation and retrofit of existing building. Now, these concepts are implemented by selecting a building performance objective. And this building performance objective is achieved by pairing what we call building performance level and seismic hazard levels. Now, what are building performance objectives then? Well, in building performance objective, you answer the question, how much damage is acceptable at a given level of shaking. So in general, in ASCE 41, there are two sets of building performance objectives. There are two main building performance objectives. One is a building performance objective for existing structure, and the other is a building performance objective for new structure. One is what we call BPOE. E stands for existing structure, and the other is BPON, that N stands for new structures. And you will notice here that that performance objective is always a function of the seismic hazard level. This is VSE. These are called seismic hazard level. And these items here are what we call building performance level. Now, at a given seismic hazard level, there's a corresponding building performance level and a corresponding risk category. You can actually think of risk category as occupancy category. And normally, if we are to relate these values here to our occupancy category, category 1 and 2 can be said to be a standard occupancy. Risk category 4 can be considered as an essential facility. So this one here, BPOE, is a performance objective for existing structure. Now this one is the performance objective for new structures. Again, the purpose of performance objective is to determine what is an acceptable damage for a given level of shaking. It tells us the acceptable damage for a given level of shaking. Now, in order to define these objectives, you need to pair seismic performance level with seismic hazard level. So what are these performance levels? Now, performance level answer the questions, what happens to the building in an earthquake? So what happens to a building in an earthquake? Would it be operational? That means after an earthquake, you don't need to move out in a building. You stay in the building, automatically it's operational. Would it be immediate occupancy? That means there's a damage, but the damage is negligible and you can return to the building within 24 hours. Or could it be a life safety where there is a possibility of loss, or a collapse prevention where there is a high probability of loss or collapse? Now, these performance levels are then paired with what we call seismic hazard level. And seismic hazard level basically answered the question, how severe is the shaking? Now, the seismic hazard level were divided depending on the performance objective. For existing structure, what we call BPOE, we have two levels of hazard. For BSE1, for 20% in 50 years earthquake, with a return period of 225, and BSE2E is a hazard level that has 5% probability of happening in 50 years. Now, for new design, we have what we call BSE1N and BSE2N, representing the first one as DBE and the other one as MCE. Now, it is important to note that there has been some changes on the definition of MCE for quite some time. Before, we just call it MCE, and now there's what we call MCER. Now, it is very important for us to recognize that there is a huge difference between these two. MCE is based on uniform hazard, and it measures what we call the probability of exceedance, while MCER is actually based on risk-targeted hazard. So what it measures is the probability of structural collapse. So when I say 2% in 50 MCE, I am referring to the 2% chance of having an earthquake in 50 years. While if I say 1% in 50 MCER, that 1% is not the probability of happening, but it's the probability of collapse. There's a 1% probability that a structure would collapse in 50 years. So those two are really different, and we should recognize this difference between these two definitions. Now, a fundamental difference between ASCE 41 and code-based is that normally when you are using code-based assessment, we are always representing the ductility of a structural building by a system ductility, we commonly referred as the response modification factor. In the contrary, when we are doing a performance-based assessment, we focus more on what we call, a component evaluation, because we want to evaluate the ductility of a building based on their member component. So that is really the difference between the two. Now, another important feature of performance-based philosophy is that, again, it has the ability to quantify the response of a building against an explicit target performance, which is not directly possible for code-based assessment. So this gives you an overview of ASCE 41. There are 17 chapters, and there are some chapters that are specifically addresses the analysis procedures and some acceptance criteria for steel, concrete, and masonry. Now, in terms of types of analysis, you can actually differentiate the types of analysis in terms of linear and nonlinear analysis. Under linear, we have two, the linear static procedure and linear dynamic procedure, which can be think of as an equivalent static procedure and a response spectrum procedure. And then we have the nonlinear analysis, which is divided into nonlinear static analysis or the pushover analysis and the nonlinear time history analysis. So what to use, linear or nonlinear? Well, if we try to define what we mean by linear, when we say linear, we do not include explicitly the analysis of inelastic behavior of members. What do we mean by this? That means we do not use the capacity of section beyond their inelastic range, and we do not consider the degradations in the structure. That is why we are only including what we call modification factor in our reinforced concrete, because we want to capture this strength degradations. No? But really, in conducting linear analysis, we are not capturing that strength degradation in structural members. Now, having these reasons, understanding this implication also would help us justify the need for us to understand and learn nonlinear analysis. Of course, when we do nonlinear analysis, there are several sources of nonlinearity. It can be boundary nonlinearity, material nonlinearity, and geometric nonlinearity. While in conducting performance-based philosophy, what our focus is on material nonlinearity, particularly plasticity, and also geometric nonlinearity, particularly P-delta effect of what we call large displacement effects. Motivations in using nonlinear analysis. Well, these are commentary taken from ASCE 4113 and 41-17, which tells us that in recognition of the improved presentation of building behavior when nonlinear analysis is conducted, the nonlinear procedures were found to have less conservative limits than the linear procedures. And buildings that are found to be seismically deficient based on linear analysis may actually comply with this standard if a nonlinear analysis is performed. So these are based on the past studies of some of the authors in the literature. Now, I will now introduce the international existing building code. So what is this IEBC and what is not? Now, IEBC was actually introduced with the objective to preserve the existing building stock by providing a reasonable set of technical requirements and associated costs. And Martin et al. Put it that it is not practical really to require buildings to be constantly updated to meet current code provisions, right? And so therefore, the objective of the IEBC is to provide some flexibility for the owners as well as the code official by allowing them to treat existing buildings differently. So what is IEBC then? Well, we can say that IEBC can be the arbitrator between those engineers who preferred code-based assessment and those engineers who preferred performance-based assessment. Because IEBC allows you to use either code-based methods or performance-based methods in conducting a seismic evaluation. Okay, let's be clear on that. So the IEBC is a model document that is already implemented in the US, and the procedure that were outlined in the IEBC allows you to use either code-based methods or performance-based method in conducting a seismic evaluation. Now, for example, the IEBC set now two procedures or two-step procedure that you can select when you want to conduct a seismic evaluation, depending on the type of work you are going to perform. So that means the selection of the type of compliance depends on the type of work you are going to perform on an existing structure. And this compliance method is actually categorized into two. One is what we call the full compliance method, and the second is what we call the reduced compliance method. In the full compliance method, you are required to use full seismic forces. And in that case, if you are using code-based approach, you will use 100% of the seismic forces determined using the current code. Or if you are using a performance-based procedure, you will use ASCE 41, Tier 3 procedure in conducting an evaluation with a performance objective of BPOM, which is equivalent to new structure. Or if your work only requires the use of reduced seismic forces, then you are allowed by this IEBC code to use only 75% of the seismic load determined using current code if you are using a code-based evaluation, or ASCE 41 with a building performance objective of BPOE. So clearly, it gives you an option. If you prefer code-based assessment, you can go with the code-based, but your seismic force the seismic force that you will use in your design shall be based on the type of work that you will be doing. So that means you will either use full seismic force or reduce seismic force. Similarly, if you are conducting performance, if you are using performance-based philosophy, if there is a certain work that would require you to do the evaluation using a BPON performance objective, and there are certain work that would require you to use or would allow you to use BPOE performance objective. So what are the work that would require compliance with seismic force? Well, when there is a change in occupancy, when there's a change in use, if there's a change in use, then you are required to use full seismic force. That means 100% of the earthquake load using code-based procedure, or a BPOM performance objective using ASCE 41. When there are addition in a structure, when there are addition in structure, again, you are required to use full seismic force, 100% earthquake using code-based, and again, BPOM using performance-based. Now, you are allowed to use reduced seismic force when there are alterations, but we need to define what do we mean by alterations. Well, alteration is any construction or renovation to an existing structure other than repair and addition. And if this is the work that you will perform, you are allowed to use reduced seismic force. So if you use code-based procedure, then you are allowed to use 75% of the seismic load calculated using new code. Or if you are using performance-based procedure, you are allowed to use a BPOE performance objective. Now, when you are doing a repair, in a structure, then you are again allowed to use reduced seismic force. Now, you are also allowed to use reduced seismic force when you are doing an evaluation of an existing structure, of an historic building. Now, we should define that a historic building is the one that should be listed or recognized by the National Historical Commission of the Philippines or as designated by a local government. So in evaluating such historical structure, we are allowed to use reduced seismic load and also reduced wind loads. That means we are allowed to use wind loads that are based on the loads in effect at the time of original construction, except when the damage is caused by wind. Okay, so in that case, we are not required to use the new wind load provision in evaluating historic structures. So as an overview of IEBC, basically there are only 15 chapters. And it is important to note that IEBC is not just focused on structural. It's a complete document that considers both fire, architectural, and other disciplines. So it is really a whole document for existing structure that is not only catering structural evaluation. Now, I would like now to proceed with presenting to you a hypothetical comparison between a code-based evaluation and performance-based evaluation of a structural beam. Now, with the introduction of the IEBC and the option for us to use either a code-based assessment and performance-based assessment, there's a natural question of, if I'm going to use performance-based philosophy and code-based philosophy, would I arrive in the same evaluation of an existing structure? That is a very natural question. Now, in order to answer this, I tried to develop a simple example that would somehow help us provide an insight on the differences between the two evaluation procedures. Now, as a disclaimer, okay, so this example does not really fully describe the procedures in both code-based and performance-based evaluation. And it is just intended to provide a high-level comparison of the two approaches to increase our insights on the difference of the two methods. So that's the purpose of showing you this example. So in this example, we are to evaluate a cantilever beam that is subjected to a concentrated load P. Now, the assumption is that this load represents already a force equivalent to a design level earthquake DBE. So it is already reduced by R, assuming. And we shall assume that for this example, that we are allowed to use reduced seismic loading. So therefore, probably in evaluating this part of the structure, the work that we are conducting, for example, is a repair, because a repair work, according to IEBC, allows you to use reduced seismic load. So what we're going to do now is to evaluate this beam using a code-based assessment. That means we are allowed to use 75% of the load, and using performance-based assessment using nonlinear static analysis. So the target solution is a code-based evaluation using 75% of the load and a performance-based evaluation using nonlinear static analysis. Now, as an assumption, this hypothetical example assumes that the load has already been determined both using code-based approach and using ASCE 41. The load P is assumed to be equivalent to a load corresponding to a seismic hazard equivalent to design level earthquake. Thus, for a code-based evaluation of reduced load, the applied load is taken as 75% of P, which is equal to 45 kilonewton. Now, for the performance-based evaluation, BPOE, because it's an existing structure, requires two demand levels, and that is a BPSE1, 20% in 50, and BSE2E, 5% in 50. And of course, we need to evaluate these two seismic hazard level according to an immediate occupancy performance level for BSE1E and according to a collapse prevention performance level under BSE2E. Now, the BSE1E load is a load that is less than DBE. So using EC8 and the work presented by Lutkowski and Alusi, we were able to approximate the load for BSE1E to be equal to 0.75 of P. Now, the demand that we use corresponding to BSE2E, of course, is expected to be higher than the design basis earthquake, but it's not greater, of course, to MCE. So again, using the same calculation above, we were able to estimate a value of P corresponding to BSE2E equal to 1.3 of P. So these are the loads that were used in code-based assessment, 45% of 45 kilonewton, equivalent to 75% of P, while for performance-based evaluation, we have 45 kilonewton under BSE2E for immediate occupancy and 78 kilonewton for collapse prevention performance evaluation. So we were able to calculate here the demand. We have 90 kilonewton meter for the flexural demand and a shear demand of 45 kilonewton. So we start our solution using code-based assessment. Of course, using code-based assessment, we calculated the demand in terms of forces, 90 kilonewton meter for flexural demand and 45 kilonewton for shear demand. Now, the capacity of the section, given this information, can now be determined using the principles of concrete mechanics. And this is what we got. The section capacity, nominal, is 124.9 kilonewton meter, and the shear nominal capacity, including the shear reinforcement, 224 kilonewton. So we were able to calculate a DCR of 0.72 for flexure and 0.2 for shear, which leads us to a conclusion that flexure controls for this beam. So this now can be now conclude that under code-based evaluation, the beam is safe. So now let's proceed to performance-based evaluation using nonlinear static analysis. Note that based on the DCR, we can already assume that the beam is deformation controlled because it is controlled by flexure. Now, of course, in conducting nonlinear static analysis, we need to model the beam by choosing a material model for both concrete and steel. Now, in this assessment, I initially checked to use the modified Hognestad method in modeling the concrete behavior, and also tried to use the Mander et al. And compare the two. Now, sometimes in modeling the behavior of reinforced concrete elements, one might forget to also model the tension behavior of concrete, but it's very important, particularly if you are modeling, if you are using fiber modeling, to actually use a model also for concrete in tension. So in this case, we just utilize a linear brittle model for concrete under tension. Now, for modeling steel reinforcement, we adopted what we call a bilinear model. Basically, it is the elastoplastic model. And in calculating the moment curvature relationship for this beam, we utilize a fiber modeling analysis. I have written a code that is based on what we call using Fortran language. And although I intend to actually transfer the code into MATLAB to make it more user-friendly. Now, in conducting the fiber element modeling and analysis, if you compare the Mander et al. Model with the modified Hogenstad model, you will see here that selecting a concrete model or concrete material model can have a huge impact in modeling, in the nonlinear modeling of your beam. And this is actually the result of the compressive stress in the beam. So you will see the difference between the two when you use a different material model. So since I consider that the Mander et al. Model is more applicable, so I use this model in developing the backbone curve for this beam. Now, using this information, I now calculated and adopted an equation for calculating the plastic hinge length in order to transform my curvature into rotation. Now, this equation was actually obtained based on the recommended equation by NISE and Lee Herb. So I was able to calculate the value of the length of plastic hinge for this beam equal to 298 millimeter. Now, using that plastic hinge length, I was able now to develop my backbone curve, which is this one, which is now in terms of moment and rotation, and it is normalized by the yielding rotation and the yielding moment. Now, of course, in modeling using nonlinear static analysis, you also need to input some of the acceptance criteria. And using these conditions, I selected a condition that is between the two, but instead of doing interpolation, I adopted the lower value in modeling the acceptance criteria. Now, sometimes when we are adopting the acceptance criteria for rotation, it is quite difficult to imagine this rotation values given in ASCE 41. So as a guide, I provided you these illustrations of rotations that were conducted in an experimental test. And you will see here that if you have a rotation of around 0.04 radian, then these are the types of cracking that you can already see in a reinforced concrete. While if you have a rotation of 0.08 radian, this is already the type of cracking that you can expect. So you can see here, if you compare these values of rotations in ASCE 41, okay, this is 0.04, so the behavior of the beam is probably in this region. So it's a good reference for you to have a visualization of the rotations that are actually presented in ASCE 41. So what are the results? For nonlinear static analysis, this is the capacity or pushover curve that was a result of the analysis using ETABS. So you will see here that the formation of plastic hinge for immediate occupancy was obtained when the load applied is 69.3 kilonewton, whereas the formation of life safety hinge was obtained when P is 60.7. Now for this beam, however, it was not able to achieve a collapse prevention performance level because after the formation of life safety plastic hinge, this beam collapsed, as can be seen by this degradation. So for this case, what we can say is that under performance-based evaluation, the beam passes the immediate occupancy performance, but failed to meet the collapse prevention performance for a BSE 2E. So as a concluding remarks from the comparison, the capacity of the beam was found acceptable using code-based evaluation, while the beam was also found acceptable using performance-based evaluation under immediate occupancy performance. However, the beam was found to be acceptable for BSE 2E, collapse prevention performance. It was found in the comparison that there was a formation of life safety plastic hinge at a capacity of 70.67. Now, if you were to compare this value, we can say that both comparisons shows that the beam is adequate under life safety performance. However, using performance-based assessment using ASCE 41, the beam was not able to meet the PPOE, particularly BSE2E, collapse prevention performance level required in ASCE 41. So to support this conclusion, if you are to read the other works, particularly that of Satar, who actually performed a detailed comparison between code-based design buildings and performance-based design buildings using ASCE 41. And this is one of the findings in the result of Satar. So you will notice here that if a building was designed using code-based assessment and using ELF procedure, and you perform an analysis using ASCE 41, if the analysis was performed using linear procedure, some of the beams would have higher DCR as compared to an analysis that was run using nonlinear models or nonlinear methods. Similarly, if you perform an analysis using response spectrum method and run this analysis using ASCE 41, again, there is a discrepancy between the results of nonlinear methods and linear methods, as you can be observed by this figure. So what is the conclusion of Satar? The conclusion is that using LSP procedure, code-compliant elements may fail to meet the collapse prevention performance of ASCE 41, which is similar to what result we have for that beam. And similar to LSP and LVP procedure, code-compliant elements also fail to meet the performance goal for the ASCE 41, particularly when nonlinear static analysis is used under collapse prevention performance level. Now, the number of elements that didn't pass the ASCE 41 acceptance criteria was higher when linear procedures are employed as compared when using nonlinear procedures. However, in the final conclusion, if you actually use nonlinear dynamic procedure, then it will show to you that even those members that fail using linear procedures in ASCE 41 can still pass the assessment if you use nonlinear dynamic procedures. So as a concluding remark for this webinar, for this presentation, so basically in this lecture, I introduce the International Existing Building Code, which can actually solve the impasse between those who are in favor of code-based evaluation and those who are in favor of performance-based evaluation. Now, both methods, as proven by several authors, can yield life safety design, with one more conservative than the other. A performance-based evaluation, however, provides us additional information, particularly when higher performance level is desired, because it allows us to select a target performance for a certain structure. Now, there are consistencies in the result of both code-based and performance-based design, and these inconsistencies are normally magnified, particularly when you are using linear procedures in ASCE 41. So thank you for listening, and I hope you learned something from this presentation.
Thank you, Doc Mac, for that very enlightening presentation. I have some few questions here from our participants. So let me read the first question. Are the evaluation of or assessment reports acceptable as legal document during litigation cases? Especially most code references are based on other countries' code, like the American code.
Okay, actually, I would say it depends on the type of evaluation you are performing. again, this is an issue about legality, and certain, it is very certain that in our practice of this profession, we are the code that we should use in order to protect us as structural engineers, really the National Structural Code of the Philippines. Now, of course, we are allowed to use as references other standards in other countries, but again, the minimum requirements of the code must be complied in order to ensure that we don't have any legal issues in this type of assessment. Again, it really depends upon the type of work that you are doing, but based on this practice that I had, it's really depend on the type of work, and I have referenced these US standards, particularly if it is a structural condition assessment, something like that. I think as long as you complied to the minimum requirements of the NSCP, I think you're good.
Okay, thank you for that. We have another question from our participants. Do we have existing codes for blast assessment in the Philippines? If there is, are we implementing it?
No, currently we don't have an existing code for blast design in the Philippines.
Okay, thank you for that. Another one is, in order to implement the use of IEBC in the Philippines, it needs to have a direct reference from the governing structural code and standards. Is the use of the provisions of the IEBC permitted in the NSCP?
Well, currently the NSCP is not referring to the IEBC, and to be actually, in fact, we don't have a code for existing structures right now in the Philippines, but IEBC was really developed as a model code, right? So any other code in other countries can actually adopt the IEBC as their code for evaluating existing structures. And that is something I think probably Sir Rani can answer in the future, probably.
Okay, yeah, that's right. In the evaluation of an engineering structure, is it not required to do NDT? I think this means non-destructive tests, together with the theoretical calculation evaluation of the strength.
Yes, as I mentioned, structural evaluation can actually consist of a structural assessment or structural analysis, or both. And in the structural assessment part, the structural assessment may include determination of in-place strength of materials in order for us to perform a structural analysis. So yes, a part of the evaluation, is determining the in-place properties of the materials, either destructive methods or non-destructive methods. However, I would like to point out that using the non-destructive methods alone is not allowed to quantify the in-place properties of materials.
Yeah, in fact, we also have a semi-non-destructive test as well as destructive test. Okay, thank you for that. Well, I think a question for if we have a copy of the lectures. I think it was answered before in the before this webinar started. Another question is, how old should be the building so that para i-assess siya for aging of structures?
Again, in the presentation, I qualify the trigger for structural evaluation, which is an aging of structure. And normally we do it when there is already some doubt, For example, physical evidence of deterioration in the structure. Or, for example, since it is aging, it may be probably triggered by seismic evaluation. And that trigger of seismic evaluation may be due to the fact that the building was constructed way back when we don't have yet a code specifically addresses earthquake detailing, for example. And in such cases, seismic evaluation should be performed on that structure in order to check, not to make the structure comply with the existing code, but really to understand the response of the structural building and to ensure that it will provide a minimum level of safety to the occupants of the building.
Yes. Okay. Another question is peer review required in using PBD in the Philippine setting? What is the liability of the peer reviewer?
Well, we don't have yet rules in the Philippines on how to do this PBD, but internationally, yes, there are requirements that a evaluation or design using performance-based approach must be peer reviewed. So that is a requirement in international setting. But based on practice here in the Philippines, when I work for some of the consulting firms, I've seen that most of this PBD are really peer reviewed.
Yeah, like the your work in San Sebastian, where there's an international peer reviewer. Okay, in performing a nonlinear analysis, can minimize or eliminate unnecessary seismic retrofit. What is the tendency of using this method?
Can you repeat that, Dr.
Okay, see, sorry for that. Performing a nonlinear analysis can minimize or eliminate unnecessary seismic retrofit. What is the tendency of using this method? So basically, it's a choice.
Yeah, so really, if you are competent in using this method, I think it's always good to use nonlinear procedures, if you are competent in using this method. So it's not that you just want to use this method because you think it will reduce the cost of doing the retrofit. But the first criteria of using nonlinear analysis is you must understand the results of the method. You must be competent enough in understanding what are the risks of using this method, because as you may see in the example that I've shown, there are several assumptions that you need to use in doing a nonlinear analysis, from the selection of material models of concrete and steel. There's already a huge variation, okay, because there are several models that you can use for modeling concrete and steel. And then there are also parameters like the length of plastic hinge. There are several equations available in the literature for you to use, or different equations that you can use in estimating the length of plastic hinge, which all of them can actually influence your backbone curve or your material modeling. And of course, the material modeling would be an important parameter when you compare it with the acceptance criteria in ASCE 41. So really the first thing to do is you must understand first the consequences or the limitations in doing this analysis. And if you understand these limitations and you are competent enough to do this nonlinear modeling, I would still advise that you use nonlinear analysis in conducting such evaluation. But it is important to remember that all engineers that are using nonlinear analysis would first perform a linear analysis in doing their evaluation, just to give you a feel about the DCR of the structure, for example.
Okay, thank you for that, Doc Mac. I have here our ASEP director, Engineer Maricon Pineda, who would like to answer this question live. Maricon? Okay, maybe let's, okay, I think Maricon's here. Maricon, you have the floor. Okay, probably Another question is, what should be considered in choosing concrete models, since there's a lot of existing concrete models?
Well, to be honest, there are no really like restriction, but of course you would need to adopt those that are commonly used by several authors in practice. And of course, one of the commonly used models is the Mander et al. Model in modeling concrete behavior.
Okay, we still have time. Okay, performance-based evaluation is highly necessary with high-rise structures rather than low-rise structures.
Can you repeat that, Dr. G? Sorry.
Yes, performance-based evaluation is highly necessary with high-rise structures rather than low-rise structures.
Oh yes, one reason for that is because tall buildings behave more non-linearly than low-rise structures. Yes, but that does not mean that you are not allowed to use nonlinear analysis for low-rise buildings.
Okay. Okay. Another question is, where did it go? If the building satisfies code-based design but fails in collapse prevention performance, does it mean retrofit is not warranted? If no retrofit will be implemented, how do we explain to the client that the building does not satisfy collapse prevention performance?
Well, number one, I think you don't need to mix the two procedures in conducting an evaluation of existing structure. So I think from the very first start, you need already to select an approach for you to follow in conducting the evaluation. So it's not that you start with the code base and then you try to switch with the performance-based philosophy. So I think you need to define that initially in your evaluation that you will use this method of analysis. And in doing so, for example, if the building did not meet a certain performance objective, that just means that under that specific target performance, your structure or structural member will not able to comply with that performance level. So in the wordings of ASCE 41, you are then fail to meet the certain performance objective criteria, because in ASCE 41, for example, if you evaluated at DSE 1E and DSE 2E and you fail to comply one of these two-level evaluation, then the entire evaluation is considered unacceptable.
Okay, related to that, Doc Mac, we have a question here. Based on ASCE 41-17 and ASCE 41-13, BSE-1N should be 2/3 of MCER, risk targeted. It is not implicitly stated that you cannot use DBE, the 475 return period. However, it is noted in the commentary that you can still use 475 return period and other return periods. Should the use of 475 be an enhanced building performance objective, like the classification of BPON for BSE-1 instead of being under BPON? It's quite a long question.
Yes, I think in the ASCE 41, aside from the two building performance objective, which is one is for existing structure and the other one is for new structure, there are other building performance objectives that we call enhanced objective, and there are also what we call reduced objective. And I think you can actually reclassify some of the seismic hazard level in order to qualify for this different level of objective. So in between the BPOE and BPON, there are some other seismic level that you can actually adopt, and they are noted as enhanced performance objective and even a reduced performance objective if you would allow additional damage to your structure.
Thank you for that, Doc Mac. What else? What will be the criteria that we will follow to know if a structure can be rehabilitated by using retrofitting techniques? Can I say that again? What will be the criteria that we are following to know if a structure can be rehabilitated by using retrofitting techniques?
Maybe if I may rephrase the question, maybe the question here is, for example, if a structure is already damaged, how can you say it can be still retrofitted? Probably that is the question, no, Doc G?
Yes.
Yeah, I think in doing an evaluation of existing structure, the first objective is to do first a gravity assessment, right? Because the gravity assessment is at the minimum, must be the minimum level of safety that you can provide. So if it can no longer support gravity assessment, then that means you don't even need to conduct a seismic evaluation, because the first thing that you should check is that the building must be able to carry the gravity loads that it supports, or so that it can continue its service.
Okay, probably one last question, Doc Mac, before we end this exciting presentation, question and answer. The challenge, here's the question. The challenge in evaluating strength of old structure is the non-availability of as-built plans. Any comment?
Yeah, I agree. No, definitely. That is one of the difficult part of doing evaluation of existing structures, particularly in the Philippines, because we don't tend to keep records of this as-built drawings that we have. So of course, the way to do it is to develop what we call as-found drawings, and develop your own drawings based on as-measured information. It is only important to note that when you develop these drawings, you must specifically put in the drawings that these are as-found drawings, and they are not as-built drawings, and definitely as-built drawings will never be the same as as-found drawings. What you need to do is just to declare to your client that these are the basis of your evaluation, or these are the basis that you use in evaluating their structure.
Okay, thank you very much, Dr. Mac, for that presentation, and as well as the exchange of questions from our participants, and your answers to those questions. Although we still have a lot of questions from our participants, as mentioned earlier by Francis Valderrama, the panelist or the speaker, Dr. Mac Mendoza, can send his comments, answers later on to questions that have not been answered in this Q&A portion. Thank you very much, and let me turn you over to our next, to Engineer Leo, who will
thank you, Doc G.
Thank you very much, Doc Mac. We will continue with this program. Thank you.